Now, the latest development from Google that it describes as a state-of-the-art quantum computer chip. The company claims the supercomputer's fastest, and it takes 5 minutes for them to solve a problem.
A routine test, a trusted system. Then something appeared that didn't belong. Google's quantum chip behaved in a way no one expected. And the response was not excitement, but hesitation. Data showed the order in which randomness should live. Screens went quiet. Conversations stopped. What followed wasn't an announcement or a breakthrough headline, but an abrupt pause that left experts uneasy. This story isn't about what was discovered, but about why it wasn't pursued. One specific result changed the direction of everything, and no one will say why. The question is simple. What made them stop? The enigmatic quantum pattern. When Google's Willow quantum chip underwent a routine superposition test, something unexpected appeared on the monitors. An anomalous pattern that was neither programmed nor anticipated. Superposition, the quantum state in which qubits exist simultaneously in multiple states, should produce results consistent with probability and randomness. Yet, this pattern broke that mold entirely. It was precise, structured, and persistent, defying all standard models of quantum behavior. Witnesses to the event recall the atmosphere shifting as senior scientists scrambled to understand the source. Normally, unexpected results lead to rigorous analysis, publication, and further study. Instead, 3 leading researchers quietly withdrew from the project without explanation. Their silence and sudden departure have raised more questions than answers in the scientific community. No papers were published describing the anomaly, and no conferences addressed the incident. This reticence is highly unusual, especially for a field brimming with curiosity and debate. The refusal to continue research suggests they encountered something unsettling or fundamentally challenging to accepted physics. What exactly this pattern represented remains unclear. Was it a processing error, an environmental disturbance, or an entirely new phenomenon? Official accounts are silent, and leaked sources hint at something that might challenge the very fabric of quantum mechanics. The core mystery hangs in the balance, awaiting deeper exploration. This unexplained event at the heart of the Willow chip's testing is not simply a technical glitch. It may point to phenomena lurking in the quantum domain that disrupt our understanding of reality itself. The implications ripple beyond computing into the philosophy of what it means to observe and know. The scientists pulling back raises doubts about the success. It implies that the information not only showed new potentials, but also brought up the basic uncertainties that were too complicated or dangerous to face directly. This has been a major setback, compelling us to reconsider what boundaries even the most intelligent people are ready to break through. At present, the pattern's implication is still not clear. However, it indicates that our control over the quantum world is very tentative. There are still parts of physics where the main principles are indistinct, and strange behaviors appear even after many years of study. The Willow chip might have pointed out such a place, which could lead to a technological and cognitive revolution. This mysterious occurrence invites us to look closer at the foundations of quantum physics, prompting a refresher on the bizarre yet fundamental principles that govern this strange realm. Quantum mechanics basics. To grasp why the Willow chip's unexplained pattern is so profound, we need to understand some core quantum principles that confound even the most seasoned physicists. Quantum mechanics governs the tiny particles that make up everything in the universe, where classical rules no longer apply. Unlike everyday objects that exist in one state or place, quantum particles exist in a haze of possibilities until measured. The cornerstone of this strange world is superposition, where a quantum bit, or qubit, can be in multiple states simultaneously. Imagine a coin that is both heads and tails at once, Not just until you look, but until you force it to make a choice. This superposed state is the fuel behind quantum computing's extraordinary power, but also the source of profound mysteries. One of the hardest puzzles is the measurement problem. The moment we observe a quantum state, it collapses from many possibilities into a single outcome, as if reality itself waits on our decision to become definite. Why this occurs remains a major unsolved question in physics. The very act of measurement or observation seems to influence reality at a fundamental level. The whole idea of consciousness being simultaneously connected to the physical state is quite disturbing. It implies a connection of observation and reality that not only misses the point, but also goes against classical logic. To this, even geniuses like Albert Einstein and Richard Feynman acknowledged this as one of the most bizarre properties of quantum theory, which remains without a clear explanation. The Willow quantum computer is not a mere observer of the quantum states, but a manipulator of them. It can control superposition and entanglement. This type of manipulation is a leap in technology that makes it possible to process as much information as ever before and in much shorter times. However, along with this jolt, there is a danger of running straight into the obscurities that quantum physics hides. The decoherence phenomenon is an additional source of confusion. It happens when interaction with the surroundings causes the quantum state to die out too soon, thereby ruining superposition and producing errors. To keep the extremely delicate quantum states alive, one has to create a very tough environment, such as absolute zero temperature, to block qubits from noise and interference. The Willow chip's ability to stabilize these states and simultaneously perform complicated operations has changed the game in this fragile balancing act. However, it further indicates that any glitch detected within its controlled system is more probably connected to the fundamental enigmas of quantum mechanics rather than random external noise. Therefore, it prepares us to appreciate the significance of Willow's prototype and success. Understanding these principles helps frame why the pattern spotted on the Willow chip's display was more than just an oddity. It touched the fundamental tension at the heart of quantum reality. The significance of Google's Willow chip. Google's Willow chip represents a significant leap forward in quantum computing, featuring 105 superconducting qubits operating at temperatures colder than deep space, just 15,000ths of a degree above absolute zero. These conditions allow the chip to preserve superposition states long enough to perform meaningful calculations without being overwhelmed by decoherence. This stability is essential for reliable quantum computation. Previous quantum machines struggled with errors caused by environmental noise and fragile quantum states, limiting their practical use. More qubits often meant more problems, as each additional quantum bit increased the chance of losing coherence and producing faulty outputs. Willow's breakthrough was its mastery of below-threshold error correction, allowing it to manage and fix errors in real time before they compromised results. This error correction enabled Willow to complete tasks in just 5 minutes that would take the most powerful classical supercomputers trillions of times longer than the universe's age itself. Such computational power opens possibilities for solving problems in chemistry, cryptography, and complex simulations that were previously out of reach. It marked a moment where quantum advantage became demonstrably real. Beyond technical specs and performance, Willow's design reflects decades of research and innovation in materials science, cryogenics, and quantum control. The choice of superconducting materials and the engineering involved in maintaining ultra-cold environments demonstrate the intersection of multiple advanced disciplines working toward this goal. However, this technological leap also meant stepping into uncharted territory. Manipulating superposition directly raises questions about the limits and behaviors of these quantum states when pushed beyond prior boundaries. The chip became a tool not only for computing, but also for probing the fundamental uncertainties of quantum mechanics. Willow was expected to usher in a new era of progress and discovery. Backed by extensive peer-reviewed validation, and global scientific support. Yet the unexpected pattern observed during one of its operations suggested that the chip might be uncovering phenomena no one had anticipated. This detail sets the stage for exploring what could lie beyond our current scientific models. The extraordinary capabilities of Willow show how quantum computing has transitioned from a theoretical possibility to a practical reality. But alongside its power lies a growing awareness of how much remains unknown about the quantum world it manipulates. A realm where certainty is elusive and strange patterns may reveal hidden truths. This delicate balance between cutting-edge technology and fundamental mystery continues to challenge scientists, leaving us to wonder what secrets Willow's discovery might unlock next. As we consider the remarkable achievements and baffling phenomena tied to the Willow chip, it becomes clear that our journey toward understanding quantum reality is far from over. The mysterious anomaly's implications. The unexpected pattern observed in Google's Willow chip did more than puzzle the scientists. It opened a window into some of the most profound and unsettled questions in quantum physics. At its core lies the measurement problem, the enigmatic link between observation and reality. The pattern suggested that the very act of measuring or interacting with these quantum states might trigger effects not predicted by existing theories.
Google's Willow chip performs 1 trillion measurements. That's more measurements than all quantum computers in history combined, and they did it in weeks.
This challenges the notion that physical systems evolve independently of observation, hinting at a deeper, unseen layer of reality. Quantum mechanics has long teased that particles exist in a haze of probabilities until observed, when all possibilities collapse to a single outcome. The anomaly seen could imply there is an active observer effect at play inside the chip's system, but in a form far stranger and more complex than previously imagined. Could the quantum states be responding to something beyond mere human measurement? A hidden variable or new principle yet to be uncovered? The philosophical ripple effects are significant. If observing quantum states influences their reality, then our concept of an objective, independent universe comes under strain. This would mean the boundary between observer and observed is more porous than assumed, and reality itself could be participatory. It forces a reconsideration of what existence means at the smallest scales, and by extension, how classical reality emerges from quantum ambiguity. Scientists have debated such ideas for decades, but until now, the questions remained largely theoretical. Willow's anomaly is one of the first times a controlled quantum device may have directly confronted us with proof that observation could affect outcomes in unexpected ways. It's as if technology has exposed a glitch or code line in the universe's foundational software. Some interpretations of quantum mechanics, like the many worlds theory, propose that all possible outcomes actually occur in parallel realities. Others suggest consciousness plays an integral role. The Willow chip's data doesn't confirm any model, but it forces open the door to these interpretations, and others that may yet be undiscovered. The line between physics and philosophy blurs. Theoretical interpretation aside, the practical ramifications for quantum computing are of utmost importance. The undisclosed pattern might signify a fresh error or stability issue that has to be tackled by the algorithms. On the other hand, it could indicate the existence of quantum effects that have not yet been explored, and might change the very nature of information processing and understanding at hand. In any case, it shows that the line between quantum technology and foundational physics has become indistinct. Routine testing, being the setting of the occurrence, only adds to its intrigue and mystique. It uncovers that even under the strict control of temperature and noise, factors known to affect the process of quantum superposition, there could be some other influence at work, which we are not yet able to explain or utilize. The anomaly thus represents both a problem to be solved and a possible entry into new physics. In any event, The anomaly obliges us to entertain the idea that our comprehension of the quantum domain, and thus the very nature of reality, may be partial. This requires not only scientific rigor, but also a certain degree of humility with respect to nature's complexity. What we perceive may just be the tip of a much larger cosmic enigma. These kinds of revelations usually disturb the scientific community, which is based on simple and reproducible results. Nonetheless, such challenges are the driving forces behind the research and lead to the unexpected paths of progress. However, in this case, they also ignited a reaction of silence and withdrawal among key researchers, raising difficult questions about what comes next. The scientists' withdrawal and silence. The sudden and quiet exit of 3 senior researchers following the discovery of the unexplained pattern is as significant as the anomaly itself. In scientific fields, groundbreaking and baffling data typically spark papers, debates, and collaborative efforts. Instead, these experts chose to step back silently, refusing to publish or communicate their findings. Their decision has sparked speculation about what could have made such accomplished scientists abruptly halt. Possible reasons for their withdrawal range from professional caution to genuine discomfort with the implications of the findings. Encountering something that threatens the foundations of physics can be intimidating, even paralyzing. These researchers may have faced a dilemma: push forward without adequate understanding and risk error, or pause to avoid premature conclusions that could mislead the wider community. Another factor could be the profound philosophical and personal impact of questioning the nature of reality itself. The measurement problem, long theoretical and abstract, suddenly became an immediate and tangible obstacle. This cognitive dissonance, balancing scientific curiosity with the weight of uncertainty, can erode confidence and stall progress. Institutional and political pressures might also play a role. The field of quantum computing is intensely competitive and connected to significant financial and geopolitical interests. Unexplained phenomena that challenge established paradigms could be viewed as risky territory, inviting scrutiny or controversy. Some researchers may have chosen silence to protect their careers or avoid conflicts. The absence of published data and open discussion leaves the scientific community in limbo. While some scientists attempt independent verification and exploration, the lack of official disclosures fuels rumors and mistrust. This opacity hinders collective understanding and delays potential breakthroughs. It's important to recognize that science is often a cautious enterprise. Negative results, unexplained anomalies, and uncertainties can lead to dead ends, and researchers may judge when it is best to retreat and regroup. Withdrawal does not mean denial of the data, but possibly a strategic pause to refine hypotheses or await better tools. Still, the refusal to continue raises profound questions about the limits of human inquiry and institutional openness. Are there areas too perplexing, too disruptive to established knowledge that even pioneers hesitate to pursue? Or does the silence instead reflect a careful process of validation and protection of scientific integrity? Whatever the cause, the researcher's retreat adds a human layer to this saga, a reminder that behind every scientific advance are individuals grappling with the unknown, with fear, hope, and the responsibility of discovery. Their silence speaks volumes, echoing through the halls of a quantum future still unfolding. Such moments of hesitation often precede new paradigms. But this pause also risks letting mysteries fade into obscurity if curiosity and collaboration do not reignite them. It invites us to ask, when technology reveals the unimaginable, who bears the burden of truth, and what are we willing to accept? The delicate balance between advancing knowledge and confronting unsettling unknowns challenges not just science, but the very nature of human understanding. With these profound reflections hanging in the air, it becomes clear that the story of Willow's anomaly is far from over, and that the true revelation may lie in what happens next. When observation shapes reality. The unexplained pattern witnessed in Google's Willow chip pushes us to reconsider the very foundations of reality as we know it.
Google's Willow quantum chip just solved a problem that would take classical supercomputers longer than the age of the universe.
Quantum mechanics has always challenged classical notions of a fixed, absolute universe. But this anomaly suggests there may be layers of reality even science has yet to fathom. It raises profound questions about how observation, measurement, and consciousness might shape the fabric of existence itself. If the act of observing quantum states can influence outcomes in unexpected ways, then reality might not be the static objective stage we once believed. Instead, it could be an intricate dance between observer and observed, where information and awareness play active roles in shaping what unfolds. Such a shift would demand a redefinition of physical laws and our place in the cosmos. This possibility stirs both excitement and unease. On one hand, it opens doors to new physics that could revolutionize technology, computation, and even philosophy. On the other hand, it confronts us with our limited understanding and forces humility amid nature's vast mysteries. The Willow chip's finding serves as a reminder that what we perceive as reality might only be a thin veil above a far stranger truth. The ripple effects extend beyond science. If reality depends on observation or consciousness in ways not fully understood, it challenges long-standing assumptions in philosophy, metaphysics, and even theology. Human experience becomes entwined with cosmic processes, blurring lines between knowledge and existence. This shifts how we perceive both ourselves and the universe. The scientists involved have gone silent and withdrawn, which makes the situation even more complex than it already is. More than likely, it is a sign that humanity is not yet prepared to accept these disturbing implications or does not have the proper mental tools to completely assimilate them. Hesitations of this nature are often at the forefront of paradigm shifts, indicating how difficult it is to go from discovery to comprehension and then to application. Meanwhile, the scientific community has practically opened the door to these enigmas and is now examining them from diverse angles. Curiosity being the primary reason for the former, and the prospect of discoveries being the main reason for the latter. Various independent groups are not only trying to replicate, but also to observe and learn about the unusual signals that are reported by Willow and other similar quantum systems at the same time. Such collaboration exhibits the power and versatility of science in tackling the most baffling problems. The human factor is what separates the tech and the theory, and it involves the management of uncertainty and the changing of knowledge. Willow's anomaly is a signpost that the way to breakthroughs is rarely smooth, and often they are costly. It demands the qualities of patience, open-mindedness, and most of all, a willingness to confront our most valued convictions. Google's Willow chip revealed more than quantum computing power. It uncovered a mystery tied to the core of reality. Scientists stepping back from the unknown remind us that discovery is driven as much by unanswered questions as by solutions. If this exploration intrigued you, like and subscribe for more deep dives into the frontiers of science and technology. And watch the next video on your screen to continue the journey.